Ever wondered how Facebook recognizes your face in a sea of millions? This marvel is made possible by a fascinating area of artificial intelligence known as deep learning. Deep learning is a subset of machine learning, where artificial neural networks, algorithms inspired by the human brain, learn from vast amounts of data. Similarly to how we learn from experience, the deep learning algorithm performs a task repeatedly, each time tweaking it a little to improve the outcome. This technology is all around us. It's how Amazon recommends products you might like, how Google's search engine provides you with relevant results, and how autonomous vehicles understand their environment. It's even used in healthcare, helping doctors diagnose diseases and treat patients. But all these applications are just the tip of the iceberg. To understand how this magic works, we have to delve into the world of deep learning. Deep learning is a subset of machine learning, which is essentially a neural network with 3 or more layers. A fascinating world within the realm of artificial intelligence, deep learning is a computational model inspired by the way our brain works. It's like machine learning, but with a twist. While machine learning models become better at their tasks with experience, they still rely on humans to provide some guidance. In contrast, deep learning models are designed to learn on their own by processing data through multiple layers of artificial neural networks. Imagine these artificial neural networks as a team of detectives working on a case. The first detective picks up on basic details or patterns, like the color of a suspect's clothing. The next detective takes those findings and identifies more complex patterns, such as the suspect's potential behavior. As information passes through each layer, the patterns get more abstract and detailed, allowing the model to ultimately make accurate predictions or decisions. These networks are designed to mimic our brain's structure, consisting of interconnected nodes or neurons. Just like the human mind, where different neurons activate for different tasks, each node in a neural network has a specific role to play. They work together to recognize patterns and learn from the data they process. Now, you may wonder about the deep in deep learning. It refers to the depth of these networks, the number of layers through which data is processed. Traditional machine learning models may have 1 or 2 layers, but in deep learning, we're talking about networks that can have hundreds or even thousands of layers. The beauty of deep learning lies in its ability to learn from unstructured and unlabeled data. It can recognize patterns and make sense of images, sound, and text, just like humans do. This ability to learn from vast amounts of diverse data sets it apart from traditional machine learning models. So, to sum it up, deep learning takes machine learning a step further. It breaks down tasks into a hierarchy of categories, each more complex and abstract than the last, and uses neural networks to derive meaningful insights from them. These neural networks enable machines to process data in a way similar to the human brain. The working of deep learning is not a mystery, but a science. So let's unravel this science. Deep learning is a subfield of machine learning, which is essentially a neural network with 3 or more layers. These neural networks attempt to simulate the behavior of the human brain, albeit far from matching its ability, in order to learn from large amounts of data. While a neural network with a single layer can still make approximate predictions, additional hidden layers can help optimize the accuracy. Imagine a neural network as a multi-layered sandwich. The bread slices are the input and output layers, and the ingredients in between represent the hidden layers. The input layer receives raw data in the form of numerical vectors. Each node in the input layer corresponds with one feature of the data. The more complex the data, the more features it has, and hence, the more nodes in the input layer. The hidden layers are where the magic happens. These layers perform computations and transfer information from the input to the output layer. This transfer is regulated by weights and biases. Weights are the strength of the connections between nodes, and biases allow for flexibility in fitting the data. In the beginning, the weights and biases are set randomly. As the data travels through the layers, the network makes a prediction. This initial prediction is usually way off. The difference between this prediction and the actual output is calculated using a cost function, and this forms the basis of the learning process. The neural network then uses an algorithm, like backpropagation, to travel back through the layers and adjust the weights and biases to minimize the cost function. This is done using a technique called gradient descent, which is essentially trying to find the lowest point of error in the cost function. This process is iterated multiple times, and the weights and biases are continuously updated. This is the learning in deep learning. The output layer is the culmination of this journey. It presents the final prediction of the neural network based on the adjusted weights and biases. Now you might be wondering, why go through all this trouble? Why not just increase the layers in a standard machine learning model? Well, deep learning models are exceptional at identifying patterns and nuances in large datasets. They outperform other models when dealing with unstructured data like images, audio, and text, making them invaluable in today's data-driven world. One thing to note is that deep learning models are a bit of a black box. While we can understand the computations happening inside, it's hard to explain why a particular model arrived at a specific output. This is a challenge in the field known as model interpretability. It's all about finding the right weight and bias to get the correct output. And that, in essence, is how deep learning works. It's a fascinating blend of mathematics, computation, and a pinch of randomness. From virtual assistants to self-driving cars, deep learning is everywhere. Let's dive into the world where deep learning is not just a fascinating concept in textbooks, but a practical, transformative technology that's reshaping our daily lives and industries at large. In the tech industry, deep learning is the brain behind virtual assistants like Siri, Alexa, and Google Assistant. These AI companions understand your voice commands, learn from your preferences, and even predict your needs, thanks to the complex neural networks that mimic human brain functions. But it's not just tech. Deep learning is revolutionizing healthcare as well. It's helping doctors diagnose diseases with unprecedented accuracy. For instance, deep learning algorithms can analyze thousands of medical images in the blink of an eye, spotting early signs of diseases such as cancer, sometimes even before a trained medical professional can. And have you ever wondered how your email filters out spam so effectively? That's deep learning too. It learns to distinguish between spam and genuine emails by analyzing vast amounts of data and understanding the patterns that characterize spam. In the finance sector, deep learning is used for predicting stock market trends. By processing historical data and trends, it helps investors make informed decisions. Deep learning is even driving the automotive industry, quite literally. Self-driving cars use deep learning to understand their surroundings and make decisions. They learn from millions of hours of driving data, constantly improving their ability to navigate complex traffic situations. The entertainment industry isn't left out either. From recommendation algorithms on Netflix that suggest what you should watch next, to AI-generated music and art, deep learning is changing the way we consume media. So you see, deep learning isn't confined to labs and research papers. It's out here in the real world, touching every aspect of our lives, making things simpler, faster, and more efficient. So deep learning isn't just theory, it's a practical technology shaping our world. But it's not all smooth sailing with deep learning. Like any other technology, it comes with its own set of challenges and limitations. One of the most prominent obstacles is the requirement of large data. Deep learning algorithms are data hungry. They need massive amounts of data to learn effectively. In many cases, obtaining such large quantities of quality data is a challenge in itself. Additionally, these algorithms are computationally intensive. They require significant computational resources which may not be readily available or affordable to everyone. This can limit the widespread adoption of deep learning, especially in resource-constrained environments. Another notable challenge is the risk of overfitting. This happens when a model learns the training data too well, to the point where it struggles to generalize to new, unseen data. Overfitting can lead to models that perform well on training data but poorly on real-world data, which is a significant problem in machine learning. Deep learning models are also often criticized for their lack of interpretability. They are considered as black boxes because it's difficult to understand why they make certain decisions or predictions. This lack of transparency can be problematic, especially in sectors where explainability is crucial, like healthcare or finance. Moreover, the field of deep learning is evolving rapidly, and with it, the need for continuous learning and upskilling. Staying up to date with the latest research and developments can be a daunting task, even for seasoned professionals. Lastly, ethical and privacy concerns surrounding the use of deep learning cannot be ignored. The misuse of this technology can have serious implications, from promoting bias and discrimination to infringing on individuals' privacy rights. Despite these challenges, the potential of deep learning is undeniable. It has the power to revolutionize various sectors, from healthcare to finance and from entertainment to transportation. It's a matter of navigating these challenges, constantly innovating, and finding ways to harness this power responsibly. After all, Every technology has its hurdles, and overcoming them is part of the journey towards progress and development. So, what does the future hold for deep learning? As we cast our eyes towards the horizon, we see a future filled with possibilities for deep learning. It's like looking at a sky full of stars, each one representing a different potential advancement or area of research. One of the most exciting prospects is the development of more advanced algorithms. These will allow deep learning models to process and analyze data faster and more accurately than ever before. Imagine a machine that can learn and adapt in real time, continuously improving its performance. Another area of focus is the integration of deep learning into everyday technology. We're already seeing this with voice assistants and recommendation algorithms, but the future could bring even more pervasive use. Think of a world where your fridge can predict what groceries you'll need, or your car can anticipate traffic patterns and choose the best route. We're also likely to see increased research into explainable AI. This is the idea of making the decision-making process of deep learning models more transparent and understandable. It's one thing for a machine to make a decision, but another for it to explain why it made that decision. There's also the potential for deep learning to drive innovations in fields we haven't even considered. It could revolutionize healthcare by predicting diseases before they occur, or transform the energy sector by optimizing the use of renewable resources. However, as with any technology, there are challenges to overcome. We must ensure that the use of deep learning is ethical and that it doesn't exacerbate existing inequalities. We also need to consider the impact on jobs and the skills required for the workforce of the future. But despite these challenges, the potential benefits of deep learning are immense. We're on the cusp of a new era, one where machines can learn, adapt, and make decisions in ways that were once the realm of science fiction. The future of deep learning looks promising, and it's exciting to imagine where it could lead us. Let's take a moment to revisit what we've learned today. We dove into the intriguing world of deep learning, unraveling its complex layers and understanding its core principles. We discovered how it works, using artificial neural networks to mimic the human brain, learning from vast amounts of data and constantly refining its abilities. We explored its diverse applications, from voice recognition to self-driving cars, underlining its transformative potential. We also examined the challenges it faces, including the need for large amounts of data and the difficulty in understanding its decision-making processes. However, we also peered into the future, envisioning a world where these challenges are overcome and deep learning becomes even more integrated into our daily lives. As we continue to push the boundaries of what machines can do, deep learning will undoubtedly play a pivotal role.